We're going to look at balancing chemical equations. I'll review over this PowerPoint widget created by Coach Ward, Lee County High School. Balancing, writing, and naming equations. Chemical reaction. Chemical reaction is defined as the process by which atoms of one or more substances are rearranged to form different substances. Chemical reaction leads to a chemical change. Reactants are the starting substances, and they are found on the left side of the chemical equation. The products are the new substances that are formed through the chemical reaction and are found on the right side of the yield sign or the arrow. Conservation of mass. It's the law. Violators will be punished by a nuclear explosion. Basically, the reactants and products have to equal the same amount, as you see right here with the scale as the example. Law of conservation of matter. Let's go into more detail with it. In a chemical reaction, matter can neither be created nor destroyed. In addition, in a chemical reaction, the amount of reactants equal the amount of products. If you have two hydrogens on one side, you must have two hydrogens on the other side, for example. Basically, the law of conservation of atoms. The number of atoms of each type of element must be the same on each side of the equation, as I just previously stated. Alright, let's look at this one. We have hydrogen plus oxygen equals water. Hydrogen and oxygen are diatomic elements. Their subscripts, which are the numbers after the letter, cannot be changed. The subscripts on the water cannot be changed as well. So as you see right here, this is your subscript number. This is your subscript number. This is your subscript number. These can never be changed. The only way we can change or balance is to put a number in front of the element or the compound. Alright, so let's go over how to balance an equation. You're going to count the atoms on each side. The reactant side, as we talked about, is this side right here, the left side. We find that we have 2 atoms of hydrogen. The subscript means there's 2 atoms of hydrogen. We have 2 atoms of oxygen. Now let's go to the product side. We have 2 atoms of hydrogen over here, but 1 atom of oxygen. Do you think this equation is balanced based on the numbers? That is correct. It is not. So therefore, let's go and look a little bit further on how to balance this equation. The subscripts can't be altered, as we said just a few minutes ago. How can the atoms be made equal? You adjust the number of molecules by changing the coefficients, basically putting the numbers at front of each element or compound. The reactants, you have 2 atoms of hydrogen, 2 atoms of oxygen. In order to balance this, we need to get basically, over on the product side, we need to get 2 oxygen. So we have to put a coefficient of 2 over here. When we do that, we end up with the following. We end up with 4 hydrogens. It is 2 times 2 equals 4. So there's our 4 atoms of hydrogen. 2 times the understood 1 is 2. Therefore, we have 2 atoms of oxygen. But now we have 2 atoms of hydrogen over here on the reactant side, but 4 on the product side. Therefore, the hydrogens are not balanced. Okay, what do we do? In this case, the oxygens are balanced, 2 and 2. The hydrogens are off. Since the hydrogens by itself, we look at the least common multiple, which is 4. Can we achieve the number 4 in this case? Yes, we can. So we add a coefficient of 2 right here. 2 times 2 equals 4. Now let's look at it. Reactant side, we have 4 atoms of hydrogen. Product side, we have 4 atoms of hydrogen, 2 atoms of oxygen, and 2 atoms of oxygen over here. Now our equation is balanced. Okay, let's look at this one. Nitrogen plus hydrogen yields ammonium. We're going to count the atoms. So we've got 2 atoms of nitrogen here, 2 atoms of hydrogen here, but over here on the product side, we only have 1 atom of nitrogen and 3 atoms of hydrogen. Therefore, the equation is not balanced. So, we'll look at doing balancing on the product side in this case, since it's a compound. So, as far as this, we see that we have 3 hydrogens, 2 nitrogens. We'll go on and focus on balancing the nitrogens. And with this, you have 2 nitrogens on the reactant side. You add a coefficient of 2 right here. You have 2 nitrogens on the product side. Alright, we have 2 hydrogens here, but with a coefficient 2 times 3 gives us 6 hydrogens over here. So basically the hydrogen is not balanced. So we're looking at this. The least common multiple of hydrogen is 6. Can we get 6 over here on the reactant side? Yes, we can. We put a coefficient of 3 over here. 3 times 2 is 6. The reactant side now has 2 atoms of nitrogen. Product side has 2 atoms of nitrogen over here. Reactant side has 6 atoms of hydrogen. And on the product side, we have 6 atoms of hydrogen over here. This equation is now balanced. Now let's look at this one right here. It's more complex. Each time when we do an equation, you have to break it down by the elements. Basically, so you do each atom. You look at copper, for example. It has an atom of 1 on both sides. Hydrogen is a separate element, so you have to break it down. And for reference, I usually do all the elements and do hydrogen and oxygen last. That's just the way I was taught to do it. But going forth with what we're talking about now, the hydrogens, you look, you got 2 over here and 2 over here. Okay. Now we go to the sulfurs. Sulfurs, we have 1, and we got different spots of sulfur, so we got 1 over here, 1 over here, so we're going to have 2 sulfurs. The oxygens will be the next thing. We have 4 oxygens over here. We have 4 oxygens in this spot, another oxygen which would make 5, and another oxygen that would make 7. As you see, all our numbers are down here. If it's easier sometimes to break it down a little bit differently, as far as counting, you can do it. You could write the separate O's and then combine. A lot of times I would suggest for beginners to actually just draw a line. Like if you have two atoms of an element, to draw two straight lines. Okay, so let's look at this. Sulfur is not balanced, so we place a 2 in front of the sulfuric acid. Now, anytime you do that, of course, you count your atoms. So now we see right there we got 4 hydrogens, 2 sulfurs, and 8 oxygens on the reactant side. Now hydrogen needs to be balanced, so we place a 2 in front of the H2O. We will count the number of atoms again, as you see. On the reactants, the coppers are still good. They're at 1 atom. The hydrogen on the reactant side is at 4. Sulfur is at 2. Oxygen is at 1. On the product side, as you see right here, after adding the coefficients, we find that we have one atom of copper. We have 2 atoms of sulfur. We have 4 atoms of hydrogen. So everything's balanced out so far. Let's count our oxygens and see how they are this time. We have 1 oxygen. We have 2 more oxygens, which equals 6. 2 over here, so we have 8. So this equation is now balanced. The method of balancing equations is known as the inspection method. It's basically a trial or error method. The only way you're going to master the skill of balancing chemical equations is by practice. This concludes this video over balancing equations. Please refer to another video I included, as well as practicing balancing chemical equations, as we go through 3 different types of chemical equations that you may encounter and how to solve them.